All right, today we are doing lecture 13. Today's lecture is going to be on multi-step equations. So last time we talked about two-step equations, right? And we said that sometimes you have more than two steps. Well, these are going to be the type that we're going to see today, multi-step equations. And these are going to involve the distributive property. So just a really quick recap of the distributive property. The way that works is you're going to have something on the outside. You're going to have something on the outside. Let's just call that A. And on the inside, you're going to have, however many terms you're going to have. You'll see two terms and they'll be separated by either a plus or a minus. So I'll put B plus C. And what you want to do is you want to take the outside number and you want to multiply it by everything that's on the inside of the parentheses. So whether you have two terms or five terms, you're going to multiply everything by what's on the outside. So A times B is going to give you AB. I bring down the plus, and then the A is going to get multiplied by the C, and you get AC. So that's how the distributive property works. And that's going to show up when we do number one. Now, for all of these problems, you're going to be doing a three-step process. You're going to be isolating the variable. Usually it's just x, but you're trying to get the variable by itself on one side. And you're going to do that by however many steps it takes you to do that, because we want the x to be equal to, whatever is going to be on the right side. So it's going to be a number. And then once you have that number, you write it in a solution set. A solution set. And it's going to kind of look like this. You're going to have the fancy brackets, and you're going to have, whatever number you have on the inside. And then the third thing you're going to do is you're going to check your answer. You're going to check your solutions. And typically, well, not typically, always, this is done by using the original equation. So you're always going to be using the original equation that they gave you to start with, right? But those are going to be the three steps that we're going to follow. And we're going to get started with number one on the problem set. So I'll just write that down. Problem sets. And let's look at the first one. The first one is 6 times k minus 8 minus 8 equals negative 98. All right. So for this equation, my variable is k. What I want to do is I want to get k by itself on the left side, which means I need to get rid of three things, right? I need to get rid of this 6 that's out in front. I need to get rid of this minus 8. Since it's so close to the k, that's probably going to be the last one to go. And I do need to get rid of this negative 8 that's on the outside. So what am I going to do first? Well, the first thing I can do is I can get rid of the minus 8 by adding 8 to both sides, or I can start with the distributive property. We can multiply everything on the inside by 6, but that's going to be your call. Either way, you're going to end up doing this. So I'm going to do the distributive property first. I'm going to multiply everything on the inside by what's on the outside, the 6. And I'm going to get 6k minus 48. Then the minus 8 is going to be brought down, and then it's going to be equal to negative 98. So notice what I did there. The first thing I did was the distributive property. I multiplied 6 by everything on the inside, and I kept everything else the same, like the negative 8 and the negative 98. But now what I can do is I can combine like terms. I can combine the negative 48 with the negative 8 because they're both numbers, right? So when I do that, I bring down my 6k and I combine the two numbers to give me negative 56. 56. and everything is still equal to negative 98. And from there, notice that you have a two-step equation. A two-step equation. So the way we did those last time is we did the adding and subtracting first. So I'm going to add 56 to both sides. That'll get rid of the negative 56. And I draw my line under that. The negative and the positives are going to cancel out on the left side, leaving me with 6k being equal to what? So negative 98 plus 56. That's going to be, let's see. Let's do 98 minus 56 and then take its opposite. So 8 minus 6 is 2, 9 minus 5 is 4. So it would actually be negative 42. Negative 42. Yep. Okay, so that's the right side. And it's a negative 42 because the biggest number is a negative, right? That negative 98. So now what's the last thing I have to do to get k by itself on the left side? I need to divide both sides by 6, right? So that's what I'm going to do next. And when you divide both sides by negative 6, the point is to get rid of the number that's in front of the variable. And then you just get k is equal to whatever you have on the right side. And in this case, it's going to be a negative 7. So inside my solution set, I'm going to have negative 7. Okay? So I only put my solutions that I know are going to work inside the solution set. But how do I know that negative 7 is going to work for sure? What I do is I check it. And that's going to be the third step or the last thing that we do. Okay? So I've got k equals negative 7. So when I go on the next board, what I'm going to do is I'm going to check this by using the original equation that we started off with. So let's go ahead and check it. All right. So for number 1, we had 6 times k minus 8 minus 8 equals negative 98. And my solution was k equals negative 7. So what I'm going to do is I'm going to replace every k with a negative 7. So I replace k with a negative 7 and I keep everything else the same. So I still have the 6 out in front. I still have the minus 8, the other minus 8, and the negative 98. And I just go from there. I do order of operations from here on out on the left side. So inside the parentheses, I have a negative 7 minus 8. That's going to be negative 15 if I was to put those together. And I keep everything else the same. So I'm still going to have the 6, the minus 8, and the negative 98. Next thing I can do is I can multiply 6 by negative 15 to get negative 90. And I keep everything else the same. The left-hand side, I can put those two numbers together, right? Negative 90 minus 8, that's going to give me that negative 98. So the two sides are equal. We call that a true statement. So that means that negative 7, my solution, is going to belong inside the solution set. And it's the only number that does. Okay? All right. Let's look at another one like that that is very similar, but it's going to have variables on both sides. Let's check out number 8 on the problem set. Number 8. I've got -5 times m minus 4 is equal to 12 minus 4m. Okay, so for this one, notice what I have on the left-hand side. I've got distributive property, right? I could multiply everything on the inside by -5. And that's the first thing that I'm going to do. So I'm going to multiply everything by -5. When I do that, I get -5m plus 20. I have a plus 20 because I have -5 and a -4. So those negatives are going to cancel each other out. And then the right side is still going to be the same. 12m minus 4m. Okay. So with these two sides, what I want to do is I want to get all the m's to one side, all the m terms to one side, and I want to have all the numbers on the other side, the regular numbers. So how can I do that? Well, I could get all the m's to the left side. I would have to get rid of this positive 20 somehow. So what I'm going to do is I'm going to subtract 20 from both sides. That will get rid of the positive 20. So what happens is on the left side, they cancel out. I have 12 minus 20, which is equal to -8. And I bring down the minus 4m. I'm not done with that yet. The next thing that I want to do is I want to get all the m terms on the left side. That means that I have to get rid of the minus 4m. And I can do that by adding. Now the m terms are going to cancel out on the right side. So I'm only left with -8 over here. But on the left side, I'm going to have minus 5m plus positive 4m. That's going to give me -1m. Okay, so I've almost got m by itself. The last thing that I have to do is divide both sides by what? -1, right? So when I do that, they cancel out. I get the m by itself, and -8 divided by -1 is +8. So that's going to go inside my solution set, +8. Okay. So let's go ahead and check. What I do when I check my work is I start off with the original equation. So I'm going to have -5 times m minus 4 equals 12 minus 4m. And what I want to do is I want to let m be 8 because that's my answer, right? My solution. So everywhere I see an m, I'm going to replace that with 8 to check it. That means I need to let the m be 8 on the left side over here, but I also need to let m be 8 on the right side over here because I have -4 times 8 now. Okay, so what can I do on the left side? I can do 8 minus 4. 8 minus 4 is 4. On the other side, I have 12 minus 4 times 8. That's minus 32. On the left-hand side, I have -5 times 4. That's going to give me -20. And then on this side, I should get -20 for it to work. And indeed, I do, because 12 minus 32 is -20. So I get that classic true statement. That means that 8 is going to belong inside the solution set. And it's the only number that does. All right, so that's number 8. I'll leave that up there for a little bit so you guys can get that copied down. And then we're going to move on to one of the last problems that I wanted to talk about on the problem set. We're going to be looking at number 7. So I am going backwards, but the reason why is because we had to do number 8 first. Just to show you what happens if you have two m terms on either side. That's exactly what's going to happen in number 7. Because in number 7, you're going to have the variable n, but it is going to be on the left side and the right side. So let's try that. Okay, number 7 says n minus 26 equals negative parentheses 1 minus 6n. Okay, so for this question, we have the n, the variable, on both sides. The first thing that I always do is I do the distributive property. We have a negative on the outside, so I'm going to multiply everything on the inside by that negative. You can also think about it as a -1, right? -1. So that's going to be on the outside. What I do is I keep the left side the same, and then on the right side, I do the distributive property. So that means I need to multiply everything on the inside by -1. So -1 times 1 will give me -1, and then -1 times -6. That's going to give me a +6 in. Okay. So we started off with the distributive property. Now what I want to do is I want to make it so that I get all the n terms on the left side and then all the numbers show up on the right side. So what are some ways I can do that? Well, I would have to get the 6n to the left side. I can do that by subtracting 6n. I can do that to both sides. They cancel out over here. And I'm only left with a -1. Over on the other side, I basically have an n minus 6n, which if you want to think about it this way, it's 1n minus 6n. That's going to give you -5n. And then I bring down the minus 26. Okay, so now all the n terms are on the left side. Now I want to get all the regular numbers to the other side. So I need to get rid of this minus 26 by adding 26. Okay, so when I do that, I get -5n is equal to 25. 25. So the minus 26 and the positive 26 cancel each other out. The last thing I need to do to get n by itself is to divide both sides by -5. And I can do that. That's going to cancel out the -5s over here. And I'm transferring all the numbers to the right side. Because what you'll see is that in the end, the left side is only going to be n, but the right side is going to be 25 divided by -5. That is -5. So that is my answer. I put it inside the solution set. Okay, so now I want to check my work. I want to make sure that the -5 is actually going to check out, right? I start off with my original equation. And then what I do is I let n be a -5 everywhere I see an n. So I'm going to let this n be a -5, keep everything else the same, and I'm going to let this n be a -5. So I actually have a set of parentheses inside a set of parentheses. See that? Now on the left side, I just have numbers. I have -5 minus 26. That's going to give me -31. On the other side, I have a bit of a mess, but I can simplify it. I have -6 times -5. That's actually going to be a plus 30. Plus 30. Because those two negative signs are going to cancel out. 1 plus 30 is going to be 31. So I get -31 on both sides. So we know for a fact now that -5 is going to be a solution for this equation. Okay. So now let's move on to some of the classwork questions, because I do see some that I do want to talk about. So let's take a look at the classwork. I'm going to be doing some even problems, so I'll just write down evens. Okay. Number 2 says 162 is equal to 7 minus 5 times 1 plus 8x. So there are actually 2 ways that you can do this one. I'm going to do the way you probably haven't thought of yet. And this is to make a point. You don't really have to do the distributive property, right? You could do that and you would still get the right answer, but I'm going to take it in a different way. So the first thing that I'm going to do is I'm going to get rid of the +7. The way I do get rid of a +7 is by subtracting it from both sides. So I'm going to do a -7 on both sides. Now that's actually going to cancel out the 7s and leave me with a -5 times 1 plus 8x. And then on the other side, I have 162 minus 7, which is 155. Okay. So now, even at this step where I've gotten rid of the 7, I can still do the distributive property, right? I can multiply -5 by 1, and I can multiply -5 by 8x. I can definitely do that. But notice that the -5 is being multiplied by everything that's in parentheses. So if I wanted to get rid of this -5, how would I do it? How would I get rid of that -5? I would divide both sides by -5. Right? That way, when I do that, the -5s cancel, and I'm only left with 1 plus 8x at the end. On the other side, I'm going to have 155 divided by -5. So I know my answer is going to be negative, but it's going to be a -31. Okay. So now I've got 1 plus 8x equals -31. I now have a 2-step equation, right? I can solve this in 2 steps by subtracting 1 first. So I do that first. And I get -32 on this side with only an 8x on the right side. So then the last thing I need to do is divide by 8. And that's going to get x by itself. Okay, so the x is by itself now, and all the numbers show up on the left side. Negative 32 divided by 8 is going to give me negative 4. That's my solution. Okay, so when I go back and check, I start off with my original equation. And everywhere that I see an x, everywhere I see that variable, I'm going to let x be negative 4 because that's the answer that I just found. So everything is going to stay the same, except for I'm letting x be negative 4. So I've got that double set of parentheses now. That's because I'm multiplying 8 by negative 4. When I do that, I get negative 32. 1 plus negative 32, that would just be minus 32. So in the end, I'm going to have 1 minus 32, which is negative 31. I can multiply that by that negative 5, leaving the 7 alone for now. And I'm going to get a positive number because I'm multiplying by 2 negatives. It's going to be 155. So then I get 162 is equal to 162. So I get that true statement again. So that's how I know that negative 4 is going to work, because I was able to check it and I get that true statement. Okay. Let's look at number 6 on the classwork. And then I'll call it a day after that. Number 6. So for number 6, it's kind of a long equation. They give me negative 4 times b plus 7 plus 2b, and it's equal to negative 24 minus 3b. Okay, so I have variables on both sides. I have distributive property going on, so I'm going to concentrate on that first. I'm going to multiply negative 4 by everything that's on the inside of the parentheses, so that when I do that, I get negative 4b minus 28. So I do negative 4 times b and negative 4 times positive 7. That's what's going to give me that negative 28. And then I bring down the plus 2b and the other stuff, the negative 24 and the minus 3b. Okay, so now I've got some like terms that I can put together, because what I notice is that I have a 2b right here, and I also have a negative 4b right here. And if I was to put those together, what would negative 4 plus 2 be? It would be negative 2b. But then everything else I keep the same. So the minus 28 comes down, and then the negative 24 and the negative 3b remain unchanged. Okay, so now I'm at that point where I want to get all the b terms on one side, and I want to get all the regular numbers to the other side. So I'm going to add 28 to both sides, add 28. And what that's going to do is it's going to get rid of all the numbers on the left side so that I'm left with everything else on the right side. So what I did was I got rid of the negative 28. Now what I want to do is I want to get all the b terms to the left side. That means this negative 3b is going to have to go over here. So how do I do that? I add 3b to both sides. What that does is that gets rid of the negative 3b, and I'm only left with a 4 on the right side. And then on the other side, I have negative 2b plus 3b. That's going to be positive 1b. Or I could just write that as just b. And then notice I'm done. I don't have to do anything else. I've got b is equal to 4. That's going to be inside my solution set. Okay, so that's how you solve number 6. My answer is b equals 4. So my solution set is just going to be the number 4. But how do I check this? I use my original equation to help me. So going on to the next slide, we're going to check with the answer of 4. Okay, so we're going to let b be 4 and see what happens. So with that being said, my original equation is negative 4 times b plus 7 plus 2b, and that's equal to negative 24 minus 3b. Okay, so what happens here? I start off with my original equation, and I'm going to replace b with a 4. So everywhere I see a b, right here, and even over here, I'm going to replace those with 4s. So I'm going to get negative 4 times 4 plus 7. Keep that in parentheses. And I have plus 2 times b. I'm going to replace the b with a 4. On the other side, I still have that negative 24 minus 3b, and I'm going to replace the b with a 4. Okay, so I can simplify a little bit. On the left-hand side, I have 4 plus 7. That's going to give me 11. Then I have 2 times 4. That's going to give me 8. So I can replace that with an 8. On the other side, I'm still going to have negative 24 minus 3 times 4. 3 times 4 is 12. So I replace that with a 12. And now the last two things that I can do is I can multiply and I can add, right? So negative 4 times 11 is negative 44. And I still have that plus 8. Over here on this side, I've got negative 24 minus 12. They're going to combine to give me negative 36. And then negative 44 plus 8 is negative 36. So I get negative 36 is equal to negative 36. And that is true. So I know that b equals 4 is going to be a solution for this equation. So you're going to be struggling with distributive property, and you're going to be struggling with figuring out how to get all the variables on one side while you keep all the regular numbers on the other side. So I hope this multi-step equations thing is going to help you out. Okay. Now you've got 2 assignments that are going to be due on Sunday. You've got your 2-step equations. That's classwork. And you've got your multi-step equation classwork. And this was done on Monday. You can do this one now today. Okay. Class dismissed. If you have any questions, you're free to ask them in the chat box. But if you don't have any questions, you're free to go. I will say that I do have some classwork videos that have been posted onto Canvas already. So if you want to take a look at those and see how I do the odd questions in the classwork, you can do so. If you have any questions about today's lecture or on any of the questions on the classwork, you can throw them down in the chat box and I will get to those very soon. All right. I will see you guys next week. Have a very mathematical day.